Madam, we will change the name, madam. You will check one time.
Which GJC, sir? Still few names are looking like M, G, K. Who all are they? How do we identify? GJC boys. Which GJC is this? Please, sir, try to understand. That's why we are asking now only to be principals here. If you make it a proper streamline, then we'll ask you to remove from the group and we'll take the only the coordinator. But initial days, we want principals to be here so that everything should be done properly. Please change the college name. This is the first priority. Otherwise, it will be very difficult for us to take the attendance, sir.
Good evening, ma'am. Shall we start?
One second.
Yes, sir, you can start.
Thank you, ma'am.
One second, I'm joining my another device.
Ma'am, am I audible?
Yes, Lucas. Shall we
Yes.
start?
Yeah, ma'am. After the recording, we can start, ma'am.
Okay. Hello, everyone. So everybody join the class, right? Shall we start? అందరూ బాగున్నారా? Class కి రెడీగా ఉన్నారు, right? Shall we start the class? Yes. So before we start the class, అందరూ camera on చేయండి. Everybody should on the camera so that I can see your faces. How could, and with those things we can know how could you understand, right? Right. Before we start the class, we are going to have a little bit of interactions, right? Right. So everybody turn on your camera so that I can see you, right? So every schools, every colleges, just turn on your cameras so that we can know how much the class is interactive and how much you understand, right? Turn on your cameras. So I will wait until you turn on your cameras, right? So guys, you are already provided with like options to on your camera, right? You have You have the access to turn on your cameras, right? Just turn on your cameras, then we will enter into the class. Super, super, super. I can see only some colleges are turning on your cameras. What about the others? I want to see every one of you. Okay. So come on, turn on first. So today, uh, we will have a class and okay. And after that, I will give you 10 minutes so that you can ask all your doubts. You can either unmute yourself and ask your doubts, or else you can just type your doubts in a chat box, right? Clear? Clear. Right. Shall we move to the class? Yes. Before getting into the class, what I want you to think of a number without which the maths can't be done, right? Not even maths. Any other subjects cannot be like we can't solve any other things, right? A single number without which we can't use computers, we can't solve anything. What is the number? Any guesses? Any guesses? Okay, the most important and the interesting number is zero, right? Right. When we think of numbers, what is the biggest number? We will imagine as much as the greatest number as we can. But when we think of an important number, what it comes to your mind? Very different numbers, right? It's just zero. How zero can be that much important? Any guesses? Yes. The thing is, so you can write 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, if zero is not invented, how could it be 10? So 10 is nothing but 1 and 0. So if zero is not invented means, so we have to keep on writing different symbols for every
Ma'am,
numbers.
hello.
Yes.
Have you switched on the camera, ma'am? Because it is not visible.
I'm going. No, I'm going to share my notepad.
Okay, ma'am. Okay. Yeah, you can continue.
Okay. Yeah. Thank you. So we have to keep on memorizing hundreds and lakhs of symbols instead of numbers. So just the invention of zero makes it much easier. When it's 10, 1 0. When it's 20, 2 0. When it's 100, 1 double 0. It goes on. So the most important number, right? Who invented it? Who invented it? Everybody knows, right? Yes, it is invented by a Indian. So it is invented by Aryabhatta, who used this zero for calculating things, right? But it is in later years it is more refined, right? Right. So what is the importance of zero? Why zero is that much important? So not only mathematical, zero is most important thing in our daily life. Right? Right. So what is the most important thing? See, 0 represents what? 0 represents what? Nothing, right? So, when we have nothing, we don't need to worry whether we have something or that. We have 0. We can easily start from this number and we can keep on working hard and hard. It will increase, right? Right. Now we have nothing, so we can have 0. So what we are going to add is, we are going to add hard work. So we can represent hard work as 1, right? Right. So every day we have nothing. So we are doing hard work. So every day we are going to add 0. So already what we are doing, we are hard working. So hard work plus our everyday life. It goes on. So when you do what we have, nothing. We can represent 0. Represent it as 0. What we are doing hard work. We represent it as 1. So hard work plus every simple things we do in your life will keep on increasing our value, right? When you have nothing in your life, don't feel sad, don't worry about that. Be clear. I have nothing in my hands. I have to create every single thing in my life with every hard work. How much is hard work I can put, right? I'm going to create my life wealthier, healthier, and as much as the greatest life on the earth. I'm going to create my life. With what I have, I have nothing. So what I'm going to do? I'm going to do hard work. So this is why 0 plays a very moral value in life. When you have nothing, accept it as it is. Right? Right. And keep on adding your hard work and the value will increase automatically. Clear? Clear. So this is the intro of my class. Now we are getting into the topic, right? Right. So what's the topic? So today we are going to see about complex numbers, right? Right. So today we are going to see about complex numbers. See, numbers we know. So what is this complex numbers? The name itself says it is somehow different, right? Right. When you say complex, so when it is very difficult, no, you say complex. So why it is complex means we are going to imagine numbers here, right? If I write this means you can simply say, ma'am, it is 7. If I write 7, I means what you say? Hey, why, ma'am, you are combining a letter with an alphabet? It seems little bit complex, ma'am. If you do that, it is very, very simple. It's an imaginary part, right? Right. So every complex number has 2 parts. So one is real part, another one is imaginary part, right? Okay. So think of our life. When we imagine, there should be a concept, right? When you think of a elephant flying in a white color means we somehow see white, somehow see elephant, somehow see a bat. Our mind just combined everything, right? Right. So we have a complex number here. So I said it is a combination of real number and a imaginary number. So where we get this imaginary number? So it is very, very simple. So now we are going to think about a square number. If you are having a positive number inside the square means, what is the square root of 25? So it should be either -5 or +5, right? So -5 into -5 is 25 again. +5 into +5 is 25. So it is solved. So what about -25? So if we have -25 means what we write? -1 into 25. So for 25, we take 5 out. It should be -1. So think, do you ever imagine of getting stuck with a minus symbol inside a square root? See, it seems to be a nightmare, right? Getting stuck with a minus number inside a square root. So when we think of something in a nightmare means it should be imaginary, right? When you are sleeping, you think of a dinosaur coming to you and you wake up, it's a nightmare. What comes there? It's a imaginary. So when negative number stuck within a square root, it seems to be a nightmare. Whenever it's a nightmare, it's an imaginary. Simply we can write it as I means imaginary. Right? Right. So the I represents I equals what? Square root of -1. Okay. So according to the normal complex number, we can represent a complex number as Z. Right? Z should contain two parts, one real number and an imaginary number. So to represent the imaginary number, we put I. Clear? Clear. And these two terms can be anything. It can be alphabet. It can be a it can be X and Y. It can be numbers. Sometimes it can be a number within a square root. So it will keep on going. Right? Right. This is complex numbers. So you can add complex numbers, subtract, multiply, and divide. As like that of a real numbers, we can do all the operations in a complex numbers, right? But the thing, what we are going to exactly study today is the geometrical representation and polar representation, right? Of the complex number, right? Right. Generally, okay. Generally, a complex number is represented as x plus iy. See, here x is a real part and y is the imaginary part, right? Right. So what I'm going to taught you here. So I am going to taught you here. What I am going to taught today is geometrical representation, right? So if we have a x and y numbers, we can just directly put it in a graph. Here x, here y, here minus y, here minus x, and we plot it somewhere. It is x comma y. So it is normal representation, right? Right. So how we represent a complex number? Any ideas? So now we are talking about geometrical representation. Geometrical representation, right? Right. So it is otherwise known as Cartesian form. So in some point, we are going to represent the complex numbers in geometrical form. So for that, we need a plane. So in normal x comma y, we can say it is a graph that contains x-axis and y-axis, right? Right. So it is little bit different. So here we need a plane, right? So the plane name is Argand plane. So we need a plane to point the complex number. So the plane name is Argand plane. So it is a two-dimensional plane, right? So this also consists of a horizontal axis and a vertical axis. So in horizontal axis, we are going to plot the real part, right? In in the horizontal axis, we are going to plot the real part. In vertical, we are going to do the, what else is remaining here? Imaginary part, right? Right. So normally it's a complex number. So how we are going to separate a real and imaginary part? If a part contains small letter I, then it's an imaginary part. That's why we separate. So while graphing, how could we plot an I? So that we are just going to take this as x comma y. We are just going to take the number alone and we are going to eliminate I only while plotting it in graph. Why we have to do that? Because we have an axis for that. So the vertical axis represents the imaginary part. That's why we are eliminating, we are not considering I here. So the real part x is taken in the horizontal part, right? And the imaginary part y is taken in the vertical axis, right? Right. So if a complex number we have is 3 comma 4, sorry, 3 plus 4i means what we need some coordinates, right, to plot the graph. So what we should take is 3 comma 4. 3 is a real part and 4 is an imaginary part. Ma'am, can you do this in a graph and show this to us? Yes, absolutely we can. Okay. So now you see the argan diagram here, right? What you see? You see two axes, right? So what you are seeing? You are seeing two axes, right? Right. Here in the see in this part. Once again, see. This is the horizontal axis, right? Right. In the horizontal axis, what we share? We take the real part. So in a vertical axis, what we take? Imaginary part, right? So here the complex number is represented as A plus IB. Here A represents the real part and B represents the imaginary part. See, initially the A is 5 and B is minus 2i. See what we have? B is minus 2, right? Right. So A equals 5. So A is real. Real is in horizontal axis. So it is a horizontal axis where 5. So here in between 4 and 6. So it should be almost 5. Right? Right. And what is the imaginary part we have? It is B. So what is the value of B? Minus 2. So where we take the imaginary part? Vertically. Right? Vertical axis is the imaginary part. So B is minus 2. Here it is minus 2. So 5 from the horizontal axis, real 5, and from the vertical axis, imaginary minus 2. So here comes 5 minus 2i. Okay. Shall we do it for some other complex numbers? So I just vary a as 2 and I am going to put b as 2. So here you can see from real 2 and imaginary 2, it is 2 plus 2i. So that you can see it is 2 plus 3i. Now we can take real numbers, negative numbers, right? Right, here it is minus 3 plus 3i, right? Right. So now what we did, we just take an argan plane. Here it contains two axes. So one is real and another one is imaginary. Right? We are going to plot the complex numbers using these two things, right? Right. Shall we move to the next one? Yes. Okay. This is one part of representation. Is there any other way we can represent it better? Yes, there is another way of representing complex number. Okay, what is that? That is polar representation. That is polar representation. Okay. Before that, I want to know whether everybody is clear with the argan plane, geometric representation, Cartesian form. Clear ga arthamainda? Shall we move to the next one? Okay. So the next one is polar representation. The next one is polar representation, right? Right. What is polar? Is there any guesses? Right. So what we are going to do is, so we are going to represent the same complex number without using imaginary and real part. Then how we are going to do that? So we are going to do with the help of angles. With the help of angles. How we are going to get the angles? See, z equals x plus iy is a complex numbers, right? Right. So to represent it is the complex number is represented in Cartesian form. In polar form. So in polar form, how we represent this complex number means, so z equals r multiplied by cos theta plus I sin theta. So this is why we are going to represent the complex number in polar form. So how we are represent a complex number in polar form? We just going to go to this one. So is that complex number which is equals r multiplied by cos theta plus I sin theta. Right? Okay. So here we at least see two numbers, x and y. So how we are going to calculate this r and this theta? Is there any other formulas? Yes, there are. So r, see, we call it as modulus, right? What we call r as modulus. So r equals modulus of z, right? Right, which is equals square root of real number square plus imaginary number square. Clear? Okay, clear? Clear. So for r modulus, so it is modulus of z. So the modulus of z formula is square root of x square plus y square. Here x is real part of a complex number and y is imaginary part of a complex number, right? Okay. Clear ga ardhamainda? Shall we move to the next part? So next part is this one. So we can call it as argument. Argument or principal angle. It contains so many names, okay? Okay. So what is the formula for this one? So formula for this one is tan inverse of. So what is tan inverse of y by x? So what is y? Y is the imaginary part and x is the real part of the complex number. Right? Right. So now in polar form we have a modulus, right? And we have a argument and an angle. How we are going to use these and represent a complex number means, see this one. This modulus gives a value, right? So that value is taken as a distance from the center, right? So if it is 4 means, for example, r equals 4 means the complex number should be 4 parts away from a center. And what about the angle? This angle shows how much angle it should be from away from the normal line. Okay, it's little bit complex ka undara. So we are going to see it in a simulation form. Shall we? Once again, it's loading. Okay. See. Okay. So here, I just keep it as 4. See here, R equals 4, right? So R equals 4, 4 means from so see in this graph we are set R equals 4. Modulus equals 4. So the complex number is 4 ports away from the center. So here it is the center 1, 2, 3, 4. So it is 4. The distance between the center and the complex number is 4. Right? Right. So and this one theta is 6.28 radian. So it is here. If I vary means once again. I hope my screen is visible now. Okay. So if I vary the theta mean, see the angle varies. So the complex number also varies. So you can change and vary, right? Right. So now you got a simple idea of how it is represented. Okay. So in this you can clearly see. Okay. Here I just varied. Okay. See, just by varying the angle, every single values varies here. So what is the complex number we have here? So it is minus 3.69 plus 3.38i. So it is a complex number, right? Right. So for this number, the value of R is 5. So the complex number is 5 ports away from the center. 1, 1, 2, 3, 4, and 5. Right? Right. So the argument value is 2.4 radian. In angles we take means 137.51 degree. So from this axis, so we are going to move the angle of 137.51 degree. So here comes it is, right? Shall we just vary these numbers and see how this one varies? Okay. See, I'm changing the radius. What happens? So if I moves in a positive value, it increases. When it goes to the negative value, it goes to the this side, right? Right. And if I shift the value of radians, arguments, the angle of the complex number varies and it moves along, right? Right. Whenever I varying this, every time complex number also changing. So for every complex number, we can find the radius, sorry, we can find R using the formula modulus of z equal z, which is equals square root of, which is equals square root of x squared plus y squared. Here x represents this real part and y represents the imaginary part, right? Right. When you take the argument means this equals tan inverse of y by x. So what we have here, so it is the imaginary part minus 1.39 divided by minus 4.49, right? Right. So now you guys are very clear about what is the polar form of complex number, right? It is very simple. We are just we are just going to calculate the R modulus, and again we are going to calculate the argument, right? By taking both the things together, we are going to plot the complex number in the graph, right? So this graph does not contain x-axis and y-axis. This moves along with the values and the angle, right? Everybody is clear with the polar form of complex numbers? Any doubts? Clear ga అర్థమైందా? Shall we move to the next topic? Shall we move? Yes. Okay. So, okay. Once again, is my screen is aware? Okay. Is my screen is visible to all? I hope it's loading. Okay. So when we take in a normal form, right? Right. So if it is x equal, so we take two complex numbers. So if we take a first complex number 3 plus 4i and a second complex number 4 plus 3i means how we should add these complex numbers z1 plus z2. We just add two things directly. 3 plus 4i plus 4 plus 3i. See, we are just going to add the real parts and then we are going to add the imaginary parts. What are the real parts here? 3 and 4. So it should be 7. What are the imaginary parts? Positive 4i, positive 3i. So we can directly say positive 7i. This is why, see, this is by the way, we just simply add the two complex number. So how you should add in a polar form? Is there any other way? Okay. So first to see that how in a polar form is represented is that one R1 multiplied by cos theta 1 plus I sin theta 1, right? Right. So we just going to multiply the R1 get into cos theta I and I sin theta I. So it will be R cos theta 1 plus I sin theta 1. Here comes on, right? Likewise, we should also have like, okay, instead of R, we can also use the value of numbers, right? Right. So I'm going to take Z1. So for Z1, I'm going to use the value of R as 2. And I'm going to use theta as theta. So what will be 2 multiplied by cos theta plus I sin theta, right? Right. So Z1 equals 2 cos theta plus I 2 sin theta. Clear? Clear. For Z2, it will be, I'm going to take R as 4 and theta as theta. So it will be 4 cos theta plus I sin theta. So when we take 4 inside, it will become 4 cos theta plus 4i sin theta. So now we have two complex numbers in polar form. So how you add z1 plus z2? So while adding, what will think of first? Real parts. Here it is 2 cos. Here it is 2 cos. Here it is 4 cos. 2 cos plus 4 cos. They both are in positive. So we can directly say 2 plus 4 is 6 cos theta. And now we are done with the real part. Now we are moving to the imaginary part. So what is the imaginary part here? 2i sin 2i sin theta. Here it's 4i sin theta. So here is 2 sin theta. Here is 4 sin theta. It both are imaginary part. So 2 plus 4 is, so we can directly say 6i sin theta. Clear? Clear. Likewise, we can do subtraction. Z1 minus Z2. So we are going to subtract Z2, the second complex number from the first one. So it will become how we are going to simply keep the first complex number as it is. Right? Right. Minus second complex number. So 4 cos theta plus 4I sin theta. Right? Right. So when you do this, 2 cos theta plus 2I sin theta minus 4 cos theta minus 4I sin theta. Clear? Clear. So here it is positive 2 sin theta. Here it is negative 4 sin theta. So what will comes? So negative 2 sin theta. So now when we take the imaginary part, here comes 2I sin theta. Here comes minus 4I sin theta. So while subtracting these two things, what we will get? We will get minus 2I sin theta. So like this, we can do addition and subtraction in complex number in polar form. So what about multiplication and division? We will do that too, right? Right. Cos theta plus I sin theta. Right? Right. Is there any other easy way to write this one? Every time I have to write cos theta plus I sin theta. Every time I have to repeat this one. Is there any other simple way to represent this? Yes, that is Ci as theta cos plus I sin theta. Clear? Clear. So cos plus I sin theta can be represented as cis theta. Right? Right. So now we are going to come to the point of multiplying two complex numbers in polar form. Right? Right. So for that we have to write. So Z1 equals R1 cos theta 1 plus I sin theta 1. And Z2 equals R2 multiplied by cos theta 2 plus I sin theta 2. So these are the two complex numbers. How we are going to multiply? Yes, there's a normal way which is going to get this multiplied into this, get this into this, and we are going to multiply the entire 2 times. It is the longest possible way. Is there any other shortcuts? Yes, there is one shortcut available. What is the shortcut? See, now we are going to multiply, right? Right. These one is a modulus, right? So Z1 and Z2 while multiplying this one, we can directly multiply the modulus first, right? We can write it as R1 multiplied by R2. Okay? Okay. So now we are going to multiply these two things. Before that, we can write it in the form of cis theta. So it will be R1 cis theta 1. So it will be R2 cis theta 2. Right? Right. So now we easily multiply the modulus value. So now we are going to multiply the angle value. It is cis theta 1 multiplied by cis theta 2. I'm going to tell you a shortcut, right? Right. So while multiplying this is theta, we don't need to completely multiply this. We just add the angle alone, right? If we have to multiply cis theta 1 and cis theta 2 means you can easily write this theta 1 plus theta 2, right? Right. So in cis theta alone, it is applicable. What is applicable? If you are going to multiply 2 cis theta means you can simply add the value of the angles, right? Right. So that multiplying two complex number in polar form is so easy. Just when you are going to multiply two complex number R1, Z1 and Z2 means just multiply the modulus first, R1 and R2, and about the angles, it is a cis theta. So just we can simply add the angles. Theta 1 plus theta 2. Clear? Clear. So now we are very clear with multiplying complex numbers in polar form. What about the division? It's very, very simple. Division. See, now I'm going to teach you a simple technique. See, for multiplication, what we did, we add. So division is a opposite of multiplication, right? So what is the opposite of addition? Tell me. Simple. Everybody knows it's subtraction, right? When it comes to division, we are just going to subtract the angles, right? Right. So here, these are the two complex numbers. I am going to divide the first by the second, right? Right. So, first we are going to take the modulus part. So it will be R1 by R2. The second part is cis theta 1 divided by cis theta 2. So it will be cis theta 1 divided by cis theta 2. As I said, if you are going to multiply cis theta 1 with cis theta 2, it will become cis theta 1 plus theta 2. So now it is a division. We are just going to replace the addition with subtraction. So it will becomes R1 by R2. So it is a division in cis theta. So we can simply rewrite it as cis theta 1, who is in a numerator, minus the one who is in a denominator. So it will become cis theta 1 minus cis theta 2. Clear? Clear? Okay. So now we are very clear with addition and subtraction and addition, subtraction, multiplication and division in polar form, right? Right. So now we are going to see some other little things in this, right? Right. One second. Okay. So now we are going to see some little things. Okay. So if you are taking a circle, right? Now we are going to think of a circle. Okay, so it is a circle. So it should be its center point, right? Right. So I'm going to take a point here on the circle, right? Right. It is a center. So, so it is a center, right? Right. So center, it is a point on the circle, right? So I'm going to represent everything in complex number. So I can take it as a Z. It is a center, right? So is it not? So what is the distance between a center and a point on a circle in a normal form? It's nothing but a radius, right? So it is nothing but a radius. So the distance between the center and the point on a circle is radius. So okay. So we can represent it in smaller, right? Right. So what should be the radius? So radius is simply the distance between a center and a point on a circle. So how could we represent this one? See. So now we are going to represent using complex numbers, right? Right. So the distance, the radius, we can say it is a distance between C and P, right? How we should calculate a distance between two complex number, a point in a plane. If we take two complex numbers means it's simply the modulus of the difference between the points. So what is the point here? Z, it's a point on a circle, minus Z naught, the center. Right? It is the radius, right? Right. So, okay. So, it is for a circle. When you think of a ellipse, okay. Once again. Okay. When you think of ellipse, so we have to take 2 points on a circle, right? So when you take ellipse, right? When you take ellipse, we can take a line and we are going to take 2 fixed points. So one should be Z2 and another should be Z1, right? If you are going to take a common point P, Z on the point is on the ellipse, right? Right. So is there any other things we have to consider here means we should know that this sum of the distance between any point on the ellipse to the two fixed point is constant, that is 2a, right? Right. So that we know distance between the distance between this one and this one's sum is 2a. See, this is the property of a ellipse. So how we can write the equation of ellipse? The thing is, we are going to add these two distances. So it should be here z. So modulus of z minus z1 plus here we are going to take this one. So z minus z2. So this is the distance between this one and this one. If we add to the two of these, we have to get a constant one. What is the constant we already know? It is 2a. So this is the equation of a ellipse, right? Right. So another important thing we need to know is locus. So what is a locus means? It is considered as the center, right? So with the locus, we can write the equation of any curve, right? Right. Shall we do a little math problem? Yes. Once again. Till now, do you guys have any doubts regarding this one? Any doubts? You can just unmute and tell your doubts. Ask your doubts so that I can clear your doubts, right? Any doubts? Or else you can say it in a chat box. Any doubts? Okay. Shall we move to the class? Okay. Okay. So now we are going to take a problem. So what is the problem here? We are provided with a complex number. The complex number is x plus iy, right? And it is represents a point in an Argand plane, right? They ask us to find the locus. So we are provided with a complex number z equals iy. We are supposed to find the locus of z such that modulus of z equals 2. right? We are just provided with two informations. We are going to find the locus. What we are provided with? We are provided with a point. What is a point? So this is a point on an argand plane. So which is a complex number. So z equals x plus iy. They are provided. What they say, they ask us to find the locus. And what they provided, modulus of z equals 2. Right? Shall we solve this one? Yes. So what we know here, what we are given with, we know that z equals x plus iy, right? And what what we are provided with, modulus of z equals 2, right? So now we are going to put this x plus iy within this, right? Right. So x plus iy equals 2. Clear? Clear. So if it is within modulus means what we have to do is we are going to put a square root, and within the square root we are going to square the real part and add that with the square of the imaginary part, right? What we have in a real part here, x, so x squared. What we have in an imaginary part here, y squared. We should add this. So I put addition symbol. So what we have here, it's 2. So now, and what I have is square root of x squared plus y squared equals 2. Right? Right. Now I am just going to move the square root to this side. If a square root is moving to that side means it will go as a square. So it will remain as x squared plus y squared equals 2 squared. So what is 2 squared? So it is 4. See, now we get a equation. So this is the, so finally we can write the locus of modulus of z equals 2 is x squared plus y squared equals 4. Clear? Clear. Clear? Arthanga unnara? Okay. Okay. One second. So I completed the class. Do you have any doubt means just unmute your mic and ask me. Or else you can clearly type your questions in a chat box so I can answer that. Any questions or any doubts? Any questions, any doubts? You have access to unmute yourself. So you can unmute and ask. Okay. You can ask your doubt. Okay. Hi. Can you ask your doubt? Are you clear with the content? Hi. Can you say or whether you are clear with the content or do you have any doubts? Okay, I hope everybody is clear with the content. So we'll wind up the session. Thank you, everyone. Thank you.
Thank you, ma'am. Shall I wind up this session?
Yes, you can wind up.
Thank you.
Thank you, Lokesh.